What feels illegal in math but really isn't?
That there are infinitely many infinities, each larger than the one before. But how can that be? Because sometimes we may describe something that's very large in size by using the term infinite. But that's because we tend to think of infinity as a number. And this is precisely why the confusion arises. You see, infinity is a concept. It means that something is endless. But for all practical purposes, there are no real-life examples where something goes on forever. So our brains haven't evolved to understand the concept of infinity naturally. However, by using Cantor's diagonalization argument, today I've taken up the task to help you intuitively understand how we can take two infinite sets, compare their sizes, and even conclude that one of them is larger than the other. But now I may have confused you fully. Because if we're working with infinite sets, then by definition, it means that they have an endless amount of elements. So no matter where you stop counting, there will always be one more. So instead of counting, we're going to use another strategy. And the principle is very simple. If you have two sets and you can pair the elements from one with the elements of the other exactly without repeating or missing, then you can conclude that the two sets have the same size. For example, the fingers on my hands pair perfectly with the toes on my feet. And so without counting, I can conclude that I have as many fingers on my hands as I have toes on my feet. On the other hand, if I tried pairing my eyes with the fingers on my hand, I would still have 8 fingers left over without any eyes to match up with. In this scenario, I can conclude that I have more fingers than eyes. This is really the gist behind Cantor's diagonalization argument. He came up with an ingenious way of pairing the infinite set of real numbers with the infinite set of natural numbers. And in doing so, he showed that there's no way of pairing every real number with every natural number without missing. When we try to do that, there are infinitely many real numbers that are left over. So guys, I'm going to go over the exact proof in another video. But don't worry, because I'm releasing this video and the other video at the exact same time. So if you're interested in the Cantor's diagonalization argument, then you can find it on my TikTok right away, and I'll also try to provide a link in the comments.